We'd like to introduce our last recipient today in the category of educators and researchers. And more than 1,400 universities and colleges around the world use RETScreen clean energy management software, NASA Power, for teaching and research. Many thousands of students learn and subsequently use RETScreen software, NASA Power, every year, and the RETScreen software and NASA Power have been utilized in over 5,000 scholarly publications to date. So we'd like to announce our recipient today as Luis Ramon Rojas-Solórzano, and I apologize if I mispronounced your name. Obviously not a Spanish speaker, but so happy to have you, Luis. You are an associate professor at 3 different universities, so a very busy person. Let me read a little bit of the description here for you by way of introduction. You're associate professor at Nazarbayev University in Kazakhstan, and professor at IMT Atlantique in France, and then professor at Simon Bolivar University in Venezuela. And Luis is a RETScreen software or NASA Power academic trailblazer. For example, since 2010, he has taught clean energy project analysis using RETScreen, which is an intensive 4-day course offered in France each year for about 20 to 30 master's students from all over the world, and has been teaching consistently the full semester course every year since 2013 for senior students of mechanical engineering at Nazarbayev University, and in the past at 2007 to 2012 at Simon Bolivar University with RETScreen and NASA Power at the center of this course. In addition to leading the course, he's also associate provost for the graduate studies at Nazarbayev University in Kazakhstan, and where he uses RETScreen and NASA Power extensively for both teaching and research, including numerous peer-reviewed publications with his students and collaborators. Thank you for joining us today, Luis. You may unmute and go ahead and give us your presentation.
Thank you so much, Paul, Greg, and organizers for this wonderful opportunity and for the award. And I want to start my presentation with the title, which is Integrating Teaching and Research in the Classroom using RETScreen and NASA Power. And this will resonate in faculty who might be attending this presentation especially. And I first want to introduce with the mission of research world-class universities. Please, next slide. Next, please. Just advance. Okay. First, what is the mission of world-class research universities? Is essentially support the development of competitive and collaborative knowledge among the international community, and this is supported on excellence in teaching and research, which are fundamental. And secondly, our mission is to prepare the new leaders in the world, being empathetic and highly skilled in new technologies. And they must be critical thinkers and have firm ethical values to serve society and to guarantee a harmonic and sustainable future for all. And to do that, let me introduce the pillars of research in world-class universities. Please, next slide. The fundamental pillars in world-class research universities is the top international students that we need to recruit every year based on a rigorous admission process, then the recruitment of top international faculty, and of course, highly qualified staff that should be also accompanying us. Together with that, we need to have a state-of-the-art research facilities, teaching, installations, a library, and of course, fundamental, robust funding. Let me now remind, for those who are here, who are linked to universities, what are the typical faculty loads in world-class universities? Please, next slide. In most world-class universities, we find that typically faculty are requested to dedicate the formula 40-40-20, essentially 40% of the time dedicated to teaching, 40% to research, and the other 20% to service. Service typically is quite easy to measure because it's related to service to the institution, service to the community, and professional service. However, research is difficult to measure because it deals with proposals, project submissions, papers, publications, book chapters, conferences, and therefore teaching and research, they are both merged together into the 80%. So please, next. So the challenge is how to meet all these three elements with excellence in today's highly competitive world. So the approach, next slide, please, that I found and many colleagues also have found around the world is by integrating research into the classroom. How to do that? Well, I personally dedicated my time to teach clean energy technologies, and this essentially raised awareness of the students about global warming, climate change, and the impact of the growing energy demand and the population growth in the world. And this has created high sensibility in students who want to learn and to put their part in solving the problem in the planet. So the approach essentially is to change from traditional learning to project-based learning, which is very appropriate for third and fourth year undergrad elective courses and for master courses. Essentially, what we do here is learning by doing. The students can use hybrid learning or direct learning methods, and they have essentially to produce a final project across the course. And this is a key element that I want to emphasize in the next slides. So the final project in my course essentially is the application of a clean energy technology in a real case study, providing practical, empathetic exercise to students to feel as future professionals and scientists. And this is the moment when RETScreen and NASA Power enter into the game, because these are a very fundamental elements, since RETScreen provides a very friendly, user-friendly platform with a robust models and very accurate database that help us to learn by doing, taking real cases motivated by the students' interest, and from that point, they can develop their projects. Please, next slide. This is an example of a typical program. Please, next, just fill the whole slide. This is a typical program of my course for undergrad senior students at Nazarbayev University, in which you can notice the introduction to the global problems of energy demand, consumption, population growth, global challenges. Then we introduce the pre-feasibility, feasibility analysis using the RETScreen tool provided with the NASA Power database. And the students also first learn how to analyze viability of different clean energy technologies. And in the left-hand side of the slide, you can notice that I typically give homeworks every week that I call mini projects. We have a debate about the first part of the course, and then there is a final project report and a final presentation. These two last elements are key in what I will present in the next slides. Please, next slide. This is a typical program in my master course that I've been teaching for the last 12 years in France, 1 week a year. And again, we have the same structure. We have the introduction to the global problem. We have the presentation of feasibility analysis using RETScreen tools, introducing all different types of clean energy technologies. And the students on the left-hand side, they have to do daily or weekly homework. In this case, it's an intensive course that I teach in 4 days. So they have to do daily courses, homework, and they have to do an examination and a final presentation project. And this, again, is a very key part of the course, final team presentation about a case study of their election. In this, I introduce RETScreen, a NASA-powered tool, to the students, and we do some cases, and then they had to select a personal interest, clean technology, to develop a case study on a real case. Next slide, please. So the approach is very simple. I pick teams of 2 to 3 students which have the freedom to choose one of the clean energy technologies that I taught during my course, and they choose the facility and the location. Typically, since these are international students in France, or mostly Kazakh students in Kazakhstan, typically they try to pick an installation that is relevant to their own countries. And in many cases, also, they pick another country of the interest. Then they use NASA Power and RETScreen to pick the fundamentals of climate data technology, and they have to do a very intensive research about the local reality. So they have to find out economic elements like capital costs, operating costs, labor costs. They have to figure out the inflation, economic parameters. All this information is rigorously searched by the students. I gave them typically a template that I prepared with a typical structure following the scientific method, in which they have to fill a template paper. And as I said, the most intensive part for them is the introduction and development of the problem and finding what is the research gap, what has been done in that place, and what has not been done that might be interesting to try as a hypothesis. Then the methodology is just following the course theory, and the analysis later is the input data, getting the output, and making the sensitivity analysis by playing with what if type analysis. Then we prepare conclusions. In the end of the course, I typically invite the best paper teams, and I challenge the students to prepare a much sophisticated version of the paper to be submitted to a conference or to a journal Q1, Q2, or Q3 Scopus. Those teams who accept the challenge, which typically are 1 or 2 per course, after 6 to 8 months after the course ends, we have about 2 to 3 rounds of reviews, and about 100% of the cases, we have been able to get the papers published. And this is very important because, you know, in our life as a faculty, we need to have research effectively presented every year. So this is a win-win situation in which faculty and students work together towards a common interest, and we meet the goal of having high-quality publications. Please, next slide. What has been achieved after 12 years running these models of teaching with research integrated? Well, I have raised awareness of my students. They are highly motivated to help tackling the global warming problem and climate change. I have worked with more than 28 nationalities because students, especially in France, they are from all around the world. We have about 15 journal publications, which are 13 of them from Q1, Q2, Q3 Scopus, 10 spring book chapters, and 19 peer-reviewed conference papers so far. So that proves that the model works, and I recommend this practice for all my colleague faculties in other universities. Thank you very much, and thanks RETScreen and NASA Power for this opportunity.
Well, thank you, Luis. We really appreciate that. And one of the things that we try to strive for is accessibility, and that includes students to be able to utilize these data products and now see how you've encouraged them to develop projects and do execute projects within RETScreen and the NASA Power. I think that is an excellent example, and thank you for your presentation today. And I would just like to, again, maybe you can use your virtual indicator there with some clapping hands. We just want to thank all those reward recipients for their presentations, and like I mentioned, we'll send out those certificates to you. And thank you again. And I'd love to interact with some of those students at some point after they graduate, and they're always welcome to interact with us if they have questions.